All right, so now we're going to be talking about 6.3, which is just kind of another short little section about solving other types of trig equations. And really, I'm just going to do a few of these, probably not as many as I would normally, just because we don't have the time. But just a couple that I would say, well, here's an equation that might come up in calculus and be good to know how to solve it. So just a couple like that. So I want to do number 17 in this section. So it's this equation here where it says, say, sine x is equal to, say, sine of 2x. And they give you an interval, say, from 0 to 2 pi. Okay. So I'll look at that equation and let me point out what you can't really do. And that is, of course, if I subtract, okay, let me just point out if I were to say subtract the sine x over, I get sine of 2x minus sine x. Hopefully you see that those are unlike terms. I can't combine these in any way. So if I got to this point and I didn't know any double angle identities, we would be stuck, right? I would be absolutely stuck at this step. Fortunately, we do know a double angle identity, that this sine of 2x is equal to 2 sine x cosine x. So I want to substitute that in here. So 2 sine x cosine x, and for the sine of 2x. Okay, and then once I make that substitution here, now I can factor out my common factor, which is sine x. And I've got the sine x and then times 2 cosine x minus 1, like this. Okay, so sine x could be 0, or 2 cosine x minus 1 could be 0. And if I go through and solve this guy right here, of course, I would get cosine x equals a half. So, kind of dusting off that unit circle, I'll write down what you would get if I look at the interval here from 0 to 2 pi. So, 0 radians could be a solution. We also have pi radians. 2 pi would not be because it's not in the interval. And then when is the cosine going to be a half? Well, that's going to happen at pi over 3 radians. And it's also going to happen at 5 pi over 3 radians. So that's it. Okay, and you can check that with the unit circle as well. Okay, let's look at another one here. So possibly number, say, 23. So 23. So I've got same interval, 0 to 2 pi radians. And I want to solve cosine 2x plus cosine x is equal to 0. Okay. Now, remember there's a few different substitutions I can make. If you remember that cosine of 2x was cosine squared x minus sine squared x. If I think about that substitution, though, is that going to help me very much? Well, it's not, because it's going to give me two different trig functions. I really want to get down to one trig function. Okay, so the one I'm going to use, convenient one to use here, is that the cosine of 2x was 2 cosine squared x minus 1. So I use that particular substitution. Okay, so I get 2 cosine squared x minus 1 plus cosine x. Of course, I would rather write it as 2 cosine squared plus cosine minus 1. And then the goal is to factor that, if at all possible, right? So If we try to factor this guy, I'm going to have 2 cosine x, and I'm going to have cosine x, and maybe I have a +1 and a -1. Is that going to be the ticket? Cosine squared, 2 cosine minus cosine, yeah. That looks good. And then I would set those factors equal to 0. So 2 cosine x minus 1 could be 0, or cosine x plus 1 could be 0. This would give cosine would be a half again, and this would give cosine being a -1. When is that going to happen on the interval 0 to 2 pi? So cosine is going to be a half. That was, we just had that, didn't we? Pi over 3 and 5 pi over 3. And when is the cosine going to be -1? Well, that is going to happen at pi. And those are our 3 solutions. Okay, so what was that one? That was number 23. Also wanted to look at 24 because this is, I can't do all of my favorite problems, right? But this is one where I do particularly like this problem. Actually, never mind. I can't do this one because I'm not going to do the other ones before that. And you're going to need to know that to do that one. Darn it. Oh, well. Now let's just stick with what we did. I think I don't want to put too much on you. Probably too late for that. But I'm trying to really just get the bare minimum, regardless of what it seems like. But yeah, I think those are good. I mean, you know how to do those equations. Those are the ones that would come up most frequently in calculus. And really, I say frequently, like maybe a couple times. Okay. Okay. I also want to do law of sines and cosines this week, so I'm going to make some videos about that, real short, and just kind of remind you what those are as well.